Okay, let's start with the basic few more problems. So let's see about the about the uh, coin problem. So one problem in terms of um, dice, two dice problem. Again, basic problem. Say to we have talked about dice tossed and coins are multiplied. What is the probability of getting say 12? Simple, like two fair dice. You can write it as a fair dice, otherwise it will be problematic. So with 12, so of course, total favorable cases would be 6 multiplied by 6 because we got 6 options. So A should be, P of A should be 36. What are the favorable cases? So we can get favorable cases as 2 comma 6, 3 comma 4, 4 comma 3, and 6 comma 2. 4 options. So the probability of A would be the getting 12 would be 4 by 36, that is 1 by 9. Simple. Now, next problem, again, this is a quite standard problem in terms of the probability with replacement, without replacement concept. So, suppose problem number 2 would be two balls are drawn one by one without replacement, right? From a bag of 3 white and 5 black balls. So what are the probability? One is the first ball is white and the second ball black. Second problem would be one ball is white and the another ball is black. So of course, in this kind of a problem, there are two things to observe. First thing is that with replacement or without replacement, this is very important for this kind of problem. So of course, if it is with replacement, then that means that you are taking out at random some ball, checking the color and giving it back. Then again you are taking it out. But for if it is without replacement, that means the number of balls is basically reducing, right? So from the 3 white and 5 black balls, if you are taking out one of the balls, of course, one ball is reducing. In this particular case, of course, you are not giving any kind of dependencies till now in this particular parts, because the first ball is given as a white ball, second ball is as a black ball. Here the sequence has been defined specifically, but the second problem, one ball is white, another ball is black, means the sequence is not defined, so you have to take care of both the sequence. So now, of course, say two balls are drawn from one bag, so always better to draw the box. So in this case we got the 3 white balls and 5 black balls. So if one ball is taken out, and if I'm solving the first problem, that is the first ball has to be white and second ball has to be black. Now since there is no dependency situations we are creating here, that means that we are can tell that okay, this taking out white ball does not depend on the taking out the next black ball. So these are independent events. PW multiplied by PB. So that means the probability of void balls out of 8 balls. If I want to get a void ball, that could be 3C1. That means 3. Now, since we have doing the without replacement, then the one ball is thrown away. That means that now the total ball there will be 7 balls are there. Now, out of 5 black balls, I have to find out one black ball. That's why 5C1, that would be 5. So, first case, it would be 15 by 56, right? Next case, that would be the one white ball and the one black ball. That means that the sequence is not given here. So, I have to take P of WB as well as P of BW. Both the cases I have to take care. So P of WB, of course, the same case, 3 of multiplied by 3 by 8 multiplied by 5 by 7. In this case, BW case, first I am taking out the black balls out of the 8 total balls. So 5 by 8 multiplied by, now there are 7 balls, 3 white out of 3 white balls, 1 white ball I'm taking out of the 7 balls. Just a reverse. So it will be 30 by, I think, 56. That means 15 by 28. Like this. That's a simple problem. Of course, this will get more complicated when we go for the base theory. So this is the
this Monday, I'm starting Tai Chi walking from Manova.
Let's go a little bit deeper, that is more complicated in terms of this kind of a problem. So let's say there is a 50-50 chance that a firm A bids for a job. Okay. Another firm B submit a bid and probability of getting the job is 3 by 4 when A does not bid, right? If firm A bids, the probability of B getting the job is 1 by 3. Then what is the probability that firm B firm B will gets the job? So there's a first is there is a 50-50 chance that firm A will bid or not. Then that is telling that okay, that another firm B is there. So another firm B is get the job and bid for the job and the get the job is 3 by 4 when A does not bid for the job. And if A bids for the job, then the probability goes down to the 1 by 3. Then what is the probability that the firm B is going to get the job? So this kind of problems, of course, and in future for the even for the your basic type of problems, always try to define the events what are given there, and from there try to understand what you need to find out. So in this particular scenario, there are two events are there that first event A, say suppose I'm writing event A, that the event of, so generally in many books will start, see that it will start writing event of something, event of this, like this way, event of that from A bids for the job. Okay. And event B would be event of that from B gets the job. Now give, say this particular scenario, what I need to find out, that is the firm B gets the job. So basically that means that I need to find out the P of B. That is my need to find out. Now what are the things are given? Given is that first line is given that there is a 50-50 chance that firm A bids for the job. That means that event of that firm A bids for the job, the probability of A, that is half, 50-50 means half. That means A is not bid for the job, that is a complement, that is also half, 50-50 chance. That means that. So A complement means that A is not bidding for the job because the situation is there in the problem. That's why they're taking that, bringing that here. So what is given, that if B is getting the job, given that A has not bid for the job. So that means that probability of that the firm B is getting the job, given that A has not uh, bid for the job, that is given as 3 by 4, and probability of B is getting the job, given that A has bid for the job, is 1 by 3. That's what is written. So A bids the job, and then B is getting probability is 1 by 3. So basically B is always getting the job is the event. So this is the thing, and I need to find out PB. If you remember that we had talked about the probability of B in terms of the complement, some equation I have given. So that equation we are going to use P of B, that is P of B by A multiplied by P of A plus P of B of A complement multiplied by P of A complement. So all the numbers are here. P of B by A is here, 1 by 3 multiplied by half, and P of B complement 3 by 4 multiplied by half. So 1 by 6 multiplied by, so plus 3 by 8. So eventually if you solve this, I think number 3 by 24. Right? So that's how basically the basis of, that's how basically we need to find out, given that this particular scenario, we can find out that what are the probabilities. Of course, the main thing is that we need to define that what are the events, and what are the kind of, given that the events, you need to define that what are the numbers are given to you. Now this particular concepts will lead to our next discussion, that is the base theorem. What is the kind of the basis of any kind of probability theorem, or any kind of, sorry, basically any kind of machine learning classification, whatever you know, those are the basis of that. So we'll try to uh, describe that in terms of kind of a cause and effect kind of a scenario. So let's try to define like this. So this is event A1, event A2, event A3, and this event B is all over there. Now this event is a effect. Say this is a effect event, and these are the cause event. Right? These are the cause events. How? Let's take an example. So event B is say uh, event of reaching late at office. Correct? Obvious, obvious if it is reason, that event of reaching late at the office. What is the reason? Can be event of waking up late. Correct. A2 could be event of traffic delay. A3 could be event of problem in vehicle. So let's assume that these are the only three reasons, possible reasons are there, and because of that, you usually get late at office, right? So now observe this A1, A2, A3 as I shown here. Those A1, A2, A3 are the mutually exclusive as well as the collectively exhaustive events. That's why I have uh, assumed that these are the only three reasons. There is no other reasons are there. So basically, if I add these three reasons, these three causes or reasons, you can say, that gives you the total probability. That is the basic assumption behind this. So this A1, A2, A3, these events has to be mutually exclusive as well as the collectively exhaustive, and the effect depends on this. So of course, I can write, okay, this event of reaching late can be depend on the either waking up late, so I can find out this probability, or I can find out this probability, or I can find out this probability, right? So basically, this effect is basically on throughout the all three problems, right? So how can I write down this particular case in terms of the our um, set scenario? So B can be written as like B intersection of A1. This is the part of B intersection A1. This is the part of B intersection A2. Not the this is the part, not the blank part. And the B intersection of A3. This is the part. Okay. So if I just add these three, I should get the total of the event B, P of A2, union of B intersection of A3, which is gives me the total event of B. Now, since these three events are mutually exclusive and collectively exhaustive, and since it is mutually exclusive specifically that this union A union B, in that if you just expand this, there should be one this intersection, this should be there, and that should be zero because these are mutually exclusive event. So now if I take this probability of B, you will see that it will come as P intersection of A1 plus P A intersection of B A2 plus B intersection of A3. Nothing but the P of I can write A1B, P of A2B plus P of A3B, right? Now again, I am going to use the theorem of compound probability just to write in terms of the dependency, because dependency is easy to compute. That's why. So I can write P of A1 given by P of B by A1, P of A2, P of P by A2 plus P of A3, P B by A3. So in summation, if I just want to write here, I'm making it as a n, P of AI multiplied by P of B of AI. So basically, as if I'm writing in terms of this is the effect, this is the effect, and these are the causes. So given that I can find out given that this is the cause, what is the probability of getting the effect, I can find out that, and probability of the causes, I can find out that eventually is giving me the total probability of the causes. So as I told, total probability of the causes, that means that it gives you the kind of measure of the totalness of the situations. So this is a, like this is the kind of a small part. So effect is given for the cause one, effect of given for the cause two. Like this, these are the numbers are here, and the probability of causes, cause one, cause two, cause three are there. If you're multiplying and adding those, finally, what is the total probability of the effect is coming here. Correct. So this particular situation, this particular line is basically is called the theorem of total probability, right? Now, in this case, if you just observe this particular line, that is the in the left hand side you got the effect, right hand side you got the cause. So, given that cause has happened, so this is kind of effect here causes. Right? Given that cause has happened, what is the probability of effect that I'm trying to find out? What if I try to find out the opposite way? What is the I given that I know the effect, what is the probability of the cause? If I want to find out this, how should I find out? The Bayes theorem tells about that if you want to find out that already you know that already this particular effect has been done, okay, that particular situation already has been done. So now I want to find out that particular cause because of that. What is the probability that the cause had happened? That if I want to find out, then I need to take the help of this particular theorem. So suppose I am trying to find out what is the probability of the A1 given that B has happened. That is because basically the statement is that given that I am late, what is the probability because of that I am getting late? What is the probability that I am getting late? That is I am trying to find out. So in the using the theorem of compound probability again, I can write like P of A1 intersection B by P of B, or P of A1B by P of B, right? Now, if I just use the compound probability here, so it will be P of A1 by P of B by A1 by P of B. And now I am going to use the theorem of total probability. From there, I am going to put the values of the P of B. Summation I want to P of AI by P of B by AI. So that means that nothing but P of A1 by P of B of A1 by P of A1, P of B by A1 plus P of A2, P of B by A2 plus P of. So basically, given that all the causes, you are actually adding all the causes here. So that's how basically you are trying to find out the probability of effect, probability of cause, particular one cause, given that that particular effect has already happened, from the probability of cause, probability of effect, given that one cause has been done. So like this, basically, this is the basically the whole theorem, the Bayes theorem. So of course, this is a kind of a basis of your classifications and many other machine learning problems. I'll just give you some words meaning in terms of the hypothesis theory or the later part of the classification. Probably the hypothesis will understand more during the hypothesis theory, obviously. The classifications probably later part when we talk about or we will learn about the machine learning or in subject, or you can read about machine learning subject, you can connect this better. So suppose if I want to show that this word's meanings in terms of the hypothesis theory in the term that if I just write a P of E1 by B, that is basically is called the push theory. posterior, basically that meaning that how probable is our hypothesis given observed evidence. We'll understand more when we'll talk about the hypothesis theory. So P A and B is basically nothing but the post theory, how the probable is our hypothesis given that observed evidence. P B by A1, it is called likelihood. That means how probable is our evidence given that the hypothesis is true. In the meaning of the likelihood, it comes like that way. How probable is our evidence given that the hypothesis is true? Likelihood again, this word again will come back later also. P of A1, this is the priori. That means how probable was our hypothesis before observation, observing the evidence. Technically, we call this as a bias. So technically, this P of A1 is the our predefined knowledge or bias towards something, some knowledge, some assumption that is basically is given by this P of A1. And P of B is called the marginal, the summation of this value. That means how probable is the new evidence under this hypothesis. What is the hypothesis? So this is the meaning of all this four unknown scenario in terms of the probability. So of course more we'll talk about this during after we understand the hypothesis theory and what are the meaning of this, how are the application of the hypothesis theory in terms of the calculations and everything. So let me just give you the basic idea about in terms of say I am using say a lot of features, right? We generally do that. We do a lot of we take a lot of features and we try to specify in terms of class, right? So what we do, so basically C is the class and X are the features. So what is the meaning of this PC given X? And if I use the Bayesian theorem, so we generally write Px by C multiplied by P of C by P of X, right? So what are the meaning of these things? C of X means that probability that the data point belongs to class C given we have observed feature X, right? That is the thing. So P of C means, as I told, the baseline, that is probability of encounter class C before looking at any current data points. Previous knowledge, basically. P of x by c, that is likelihood. That means how frequently the observed features x appears within training example. That will belong to. So this is basically updations happening here. And finally x, that is called the predictive prior. That is nothing but the probability of observing features across the dataset. So this is update. This is the predictive priors, basically options you are getting. This is previous information and this is the output. Basically, you are expected in terms of the given feature. Okay, this is the class I should go for. So this is the things keep on updations during your training process. That's what happens. That's what happens in some basic of the machine learnings. Anyway, these are the kind of future mostly we'll talk about the hypothesis theory, and if you later part, if you talk about we will learn about the the machine learnings and basics of the like how the basic theorems is generally used for the classifiers and all this. So we'll talk about that point of time. Now, before that, of course, some basic form, basic application of the your base theorem. So let's go for that. This view. Okay. Simple problem number one would be say assume a factory has two machines. Past record shows machine one produces 30% of the item. Machine two produces 70% of the items. Moreover, 5% of the items produced by machine one is defective, whereas machine two produces 1% defective items. So if drawn at random, from set of defective items, what is the probability it is produced by the machine 1? So the opposite. The first initial is to let, okay, given that you are taking out the from machine 1, the probability of getting defective item is 5%. Now the opposite way, given that you are taking out from the defective parts, what is the probability it is coming from the machine 1? So obviously, we need to again define in terms of the cause and effect. So what are the effect? Effect here, say suppose it is D, I'm defining as D. So event of drawing a defective item, right? Now what is the cause here? Cause is coming basically event of drawing a product from machine 1 and event of drawing a product from machine 2. Right? So what are the things we know? Probability of A1 we know. Drawing a product from the machine 1 is 30%, that is 0.3. Probability of drawing a product from the lot, that is 70%, that means 0.7. The probability of defective items, given that is coming from machine 1. So here the effect, given that you are having the cause, that is given that you are drawing it from machine 1, what is the probability of defective item? That is 0.05. Probability of defective items, given that it is coming from machine 1, 2, it is 0.01. What I need to find out, probability of getting a defective item, given that it is a defective item, what is the probability that it is coming from machine 1? Given that this is a defective item, what is the probability it is coming from the machine 1? So effect by, cause by effect, cause 1 by effect. So if I use the Bayesian theorem here, so P D by A1 multiplied by P of A1, my total case, that is P of D by A1 multiplied by P of A1 plus T of A2 multiplied by A2. Here only two mutually exclusive and collectively exhaustive events are there. So only two cases are coming. Maximum cases you will see only two cases only come. So just put the numbers. P by A1 is 0.05 multiplied by 0.3 divided by 0.05 multiplied by 0.3 plus 0.7 multiplied, sorry, 0.01 multiplied by 0.7. So eventually 15 by 22.68. That means that 68% chance is that given it is a defective item, it is coming from machine 1. Of course, the other number would be 31%, something, 32% something. Like if you mix for the machine 2. Similarly, another problem. So eventually we are going to the tough one. So second problem would make something like this. There are two identical boxes, identical boxes containing respectively four white and three red balls. So this is for the box one, and four white, three red balls, and three white and seven red balls. So the box two, and the box both boxes are identical. So a box is chosen at random, and a ball is drawn from it. If the ball is white, what is the probability that it is from the first box? So the problem is that two identical boxes are there. That means the probability of getting the boxes would be same. That is about like half, right? So that is one thing. So if this kind of thing, some of the word is there, like identical scenario as the identical boxes are there, that means that it is the probability of getting either the boxes same. So it is box one and box two. Each and every box would be probability of getting the box would be half, right? Now, of course, in this kind of box kind of a scenario, it is always better to draw the boxes, like the content of the boxes. Say this is box one, this is box two. So first case we got the four white and three red balls. Second case you got the three white and the seven red balls. Right. So this is the case. Now one box is chosen at random, and the ball is drawn from it. So and it is come out to be white ball. Right. So what is the effect? Effect here is the event of the ball drawn is the white ball. That is the effect, obviously. But the cause could be that you have chosen the box one, you have chosen the box, or you have chosen the box two. Let's take them as a cause and effect, and then from there let's try to understand what are the probabilities can be. So, what is the effect here? That is event of the ball drawn is a white ball, right? Now, what are the causes? So, B1 event of choosing the first box, and B2 would be event of choosing the second box. Events. So let's find out what are the probabilities are given here. So event of choosing white box, sorry, first box or the second box, sorry, choosing second box would be same. That is always half. Now, probability of effect by cause, that is probability of drawn a white ball given that you have chosen the box 1, that would be, of course, there are total 7 balls are there. Out of 7 balls, how many 4 white balls there? 4. So 4C1, that would be 4. Similarly, probability of A given B2, that is probability of getting a white ball given that I have chosen the box 2. Again, total number of ball are there, I think 10. And out of the 3 white balls, I have to choose 1 white ball. So it will be 3 by 10. What I need to find out? Probability that given that I have got a white ball, what is the probability that it came from the box 1? So cause 1 divided by the effect. So this theorem tells me how to write P of B1 by P of A by B1 by P of B1 multiplied by P A of B1 plus P of P2 given by P of A of B2. Right? So let's put the number. So B1 would be half multiplied by P of A of B1 is 4 by 7. 4 by 7 plus half 3 by 10. So eventually if you solve it, it should come something like 40 by 61 or 0.655. So that would be that given that you have got a white ball, what is the probability of the that it is coming from the box 1. The last problem for the previous theorem is a kind of again typical ball problem. Two boxes contain respectively 4 white and 2 black balls. Say this is box 1 and 1 white and 3 black balls. So this is box 2. So one ball is transferred from box 1 to box 2. What color, everything, we have no idea. So just one ball is transferred from box 1 to box 2. Then one ball drawn from box 2 and it turns out to be black. Right? What is the probability that the transferred ball was white? So two boxes contain the respectively 4 white and 2 black balls in the box 1 and the 1 white and 3 black balls in the box 2. So one ball is transferred from box 1 to the box 2. What color, we have no idea. Then one ball is drawn from the box 2. After transferring from one ball from box 1 to box 2, I am taking out one ball from the box 2 and it turns out to be black. asking what is the probability that we have transferred the white ball. Now, of course, this scenario is a kind of a hypothetical. In that scenario, that okay, I'm having this kind of a structure. Now, if you take this scenario in terms of a white as a say um, digit 0 and black as a digit 1, and you think this box 1 is a sender and box 2 is as a receiver, you might have seen some kind of a some kind of a a digital communication kind of a concepts we'll find out in this particular problem. So probably as if you are sending, I mean, you have some set of 0 1 numbers and you are sending one digit one by one, you are sending some digit and you have no idea in between there could be some kind of noise or some kind of corruptions could be there, and there whatever number you are getting, which is something else, probably you are sending 0 and it is going as a 1, then you might have been interested that given that the scenario this may happen, that what is the probability that you have sent 0 and I have got 0, or you have sent 0, I have got 1, something like that. So this problem are kind of a mimicking kind of a problems in the from the digital communication. So anyway, leave it. So how we can solve this? So again, as I told, like given that this particular kind of a problem, it's always better to draw the image of the two boxes. So box 1 and box 2. So box 1 has four white ball and two black balls, and here I got one white ball and two three black balls. Okay. So this is the case. So one ball is transferred here from here to there. No idea what is the. Now we are taking out one ball and all found out this as a black. That is the scenario. So again, we have same concept. We have to define the cause and effect. So effects are quite clear here. That the effect is a ball drawn from second box is black. That is the effect. Cause, what could be the possible causes? The effect. This has the causes. Cause number 1, transferred ball from the box 1 to box 2. Say it is, could do two options, either it is white, and second cause would be the transferred ball B1 to B2 is black. Right? So what should I find out? I have to find out probability of transferred ball is white, given that I have got a black ball. That's what I need to find out. Now, if I use the Bayes theorem, so what would be the equation I should write? E by B1 multiplied by P of B1 divided by P of E by B1 multiplied by P of B1 plus P of E by B2 multiplied by P of B2. Correct? So now let's find out these numbers in terms of the problem. So what about the P of B1? What's the meaning of P of B1? The transferred ball from box 1 to box 2 is white. So of course, the transferred ball, so in this scenario, box 2 is not there, as if like you are sending from box 1, that is out of the 6 ball, I have to find out the 1 ball out of the 4 white balls. So it would be typically 4C1, that is 4 by 6. So it would be 2 by 3, P of B1. P of B2, same thing. So out of 6 balls, I am sending a black ball. So there are 2 black balls are there. So out of 2C1, so 2 black balls and total ball is 6, so it is 1 by 3. That is okay, fine, good enough. Now what about this P of A by B1 of A by B2? So let's first observe P of A of by B1. What is the statement for P of A by B1? That means that probability of B1, that means that probability of transferred ball, given that the transfer ball is white, what is the probability that your ball is your drawn ball is black? So if I say transferred the white ball, if the ball is transferred ball is a white ball, what is the composition of the black box 2? Now in the box 2 there are 2 white balls and 3 black balls, right? You transferred a white ball, yeah, right? You transferred a white ball. If you transferred a white ball, that means that this is a given that means that thing has already happened. So you got this transferred to white balls. Now in the box 2 there are 2 white balls and 3 black balls. So out of that 2 white balls and 3 black balls, I need to find out what is the probability of a black ball. So 3 out of 5 balls need to 3C1. So 3 black balls, that will 3C1. And total ball number is 2 white and 3 black. So that's why 5. So that is 3 by 5. Now what is probability of A by B2? So now given by B2, that means that you have transferred a black ball, correct? You are transferring a black ball there. So now the composition of the box 2 is 1 white ball and the 4 black balls. So total 5, anyway it is total 5. So out of now 4 black balls, you have to choose 1 black ball, right? So now it has become 4C1, that is 4 by 5. So that's how basically you can find out, given the statements, you can find out that what are the numbers it could be. So now it is quite simple, just a sorry. So just put the numbers, nothing else. So P1 given A is A by B1. So A by B1 would be A by B1 is 3 by 5 multiplied by 2 by 3. 3 by 5 multiplied by 2 by 3 plus how much by 4 by 5 multiplied by 1 by 3. Okay. So we simplified this, I think it should become 3 by 5. So basically the concept is that given that scenario, always try to find out that what are the steps in terms of like it's a statement in terms of the whatever event we have defined, and the basis of the event we have defined, what are the this particular dependent probability are going to talk about. So basically this is the concepts, and that's how basically we can find out, or we can use the Bayes theorem. Of course we are going to talk about the Bayes theorems probably the last class, given that we have already done everything, and on the basis of that if you can find out time, that we can talk about the basis of the machine learning, that how we can classify given that say we have a number of features, how we can put the points, data points that in this particular class 1, class 2, or probably if it is a 2 class classification, class 0 and class 1, how we can put on the basis of this particular problem, and how we define that, we may talk about that point of time. But of course, this is the probability basics of our for our statistics. So of course, before going to the their classifications and all this, basis of the how the probability can be comes into the statistics. So of course, since we are talking about in terms of the statistics, in the statistics basis was, if you remember, the mean and standard deviation, right? So how the probabilistic mean can be used, and how the probabilistic statistical probabilistic standard deviation is there. So we'll talk about that in the next class. Of course, the mean would be here we'll call as a gain, or the something is called the expectation or the gain for say any kind of, you'll see the gamblings and all the kind of games, how the statistics or the expected mean or gain basically gets applied. You will see those things, and of course with this standard deviation, though standard deviation does not have any specific name or some kind of extra name, you will see that there are the applications. How, I mean, so given such kind of a game, you should play that game or not, and given that you are playing the particular game for a long time, what kind of expected mean or what kind of expected gain you can expect from that particular game, that we'll see the next class. Sorry. And in the meantime, so since we have the three lectures, so I'll share the all the till this particular part, the notes of the three lectures. My handwritten notes should be there about the three lectures, and the first assignment I'll share by next week. So I guess I got the email IDs. So I'll share the first assignment. Please make sure you are getting the mail by next week. So if you are not getting the mail, please let me know by next class that you are not got the mail, so I can share if I'm missing somebody. And it will be a till the probability basic of the probability. I'll put some questions. So basically, mostly it will be on the correlation, regressions, and the probability basic questions. So of 25 marks, as we have talked about, like we are going to give 4 assignments. So of course the assignments is expected to, you just you write it in a plain paper, scan it, or you can take a photo, good quality photo of it, and make a PDF and upload in the Google Form. I'll share the Google Form links also. And please make sure you keep the same name for each and every assignments, because otherwise it will be very difficult to understand. Okay, if your surnames or names are getting changed, so it is better if you can keep the names properly with the PRN numbers. If you have one PRN numbers. So yeah, that's it. And I'll share the book names also on the same mail. I'll share the book names. I think I have talked about the book names. Anyway, I'll share the book names as well as the assignment, as well as the whatever till the portions, the notes I'll share. Anything, any questions? Anything, any part you need to focus, or you want me to go one more time, or any more examples you need, or anything. If you have any kind of suggestions, please mail, or you can tell me now, or you can mail me also. So anything. Nothing. Um, okay. If you do not have anything, then okay. So please wait for the mail, and see you guys next week. So we'll talk more about the random variables and the um, random variables and the application of the probability in the statistics in the next class. Thank you.